let's have a practical demonstration on two-way ANOVA. So how it works, already discussed, right? One dependent continuous variable, and there are two or more independent categorical nature grouping variable, right? So let's see. Here two-way ANOVA, you can see. Let's see the data set. This data set has a sales column. I need to. I think okay, it's not coming right. No issues at all. See, this anti-fast data set has a set of column where gear, cycle, cylinder, CYL, right? Gears, CYL and MPG, those variables are listed in that Excel file in a data set, like this kind of data set, right? So we are taking MPG as a dependent variable and independent variable gear. That gear has three or more categories over there, and another independent variable cycle. That cycle has three or more categories inside of it, right? This kind of situation we use two-way ANOVA. As earlier said, this dependent variable must follow the normal distribution. We know it is already followed. We have used tilde, then we have used gear and cycle. Those we consider as a factor because those are the categorical in nature. That's why. And DF means those data from that table we are extracting MPG as a dependent variable and both gear and cycle as an independent variable. This kind of situation we use two-way ANOVA. When what summary table says, see summary, let's say summary table here, right? AOV DF double MPG tilde factor DF double gear plus factor DF double cycle data equals to DF, right? Here you see that we can see, right? This gear and cycle has a significant value. Means this gear and cycle has a different mean if you compare to MPG. Means this gear and based on the gear and cycle there is a difference in mileage. It talks about based on the gear and cycle the mileage is difference. So you can see I have here since p value is less than 0.05, therefore gear and cycle has a positive positive MPG on mean in different across categories. It means which are different across categories. Means this categories gear and cycle has a difference mean across categories if we see the predicted MPG, right? Those gear and cycle will affect the dependent variable, right? If different gear has a different mileage, we already did in the first, and different cylinder has a different mileage. So that is what it says, right? Significance, p value significance. Accepting that the mean of the one of the mean of the it accept the alternative hypothesis say that mean is different across categories. It says, right? If it is not mean, there is no difference on mean. But we got 0.05 for both gear and cycle. That's why mean is different across categories. So this is simple cross. Also you can look the cross. For cross you have to use multiply, right? Here you get simple gear and cycle. If you do cross like this, you will get, okay. I think factor and this is insignificant, not significant. If we cross that is not significant. But what if we did not? If we just add it, we get significant value. Similarly, we have a data set called sales data. Here you can see sales data has a number continuous variable, which we call it as a dependent variable, and advertisement low, high, medium, low, high, right? With two categories, and there is price has a low, medium, and high, three categories. So with this advertisement and price, how it predict the sales, that's what we are seeing, right? Now look, we are saving this sales data to the DF, and if we view that, we will see this after that sales data with interaction. If you do the interactions, what we see, only we can see you can do plus also. For interaction, you will get one more like this, right? This is insignificant. But if you do plus or something, right? If you do plus, you'll get two values only. Out of these two, only price has a significance value, other two values are insignificant. Means price had based on the price this sales is differ. Means price, because this is significant effect, right? That's why mean is different across different, mean is different across price, right? Different price can have a different sales. So what it says, based on the output only price a variable which categorized in three groups, low, medium, high, is found to be statistically significant with the sales of the new product. That's what the interpretations. Now let's see. We know that in a previous one also, right? Here we understood that price is the one who has a different mean across categories, right? Means there is a significant effect on price. Price get when price has a different value, that sales also might have a increased or decreased, right? It gets affected by price. Sales get affected by price because it has a mean different mean, right? Different mean value, because P is significant. So what we do, T apply function, here we keep that sales and another which was the independent variable which is significant, that is price, right? And we do give command mean and see. So this is the output, high, low, medium. So looking this high, low, medium, can you just tell which one is best options, best for this? Because high is only 393, low is 777, medium is 543. So we can easily, based on the output, highest sales is 777.625. So lowest price we must consider, because that lowest price has a highest sales. So based on the here events, based on the output, the highest sales was obtained for low price. We must focus on these prices. So that's all. Okay, that's all the interpretations. Thank you very much.